One of the challenging topics for A-level chemistry student is using the IR NMR spectra to identify structure of an unknown compound. I'm going to go over one of the past paper questions, but rather than just answering the question, I'm going to give you some tips how to use the different spectra to identify the structure. And you can apply the same method for any unknown structure. So in this question, they made our life a bit easy because they gave us the molecular formula, which is C7H12O3. So now I know I don't have any nitrogen or any halide, so I don't need to worry about nitrile groups or about any amines or about even carbon chloride or any of these bonds. Now let's start with the IR. What information can I get from the IR? I can see this peak, which is this sharp, strong peak here at 1725. When I look at the IR, I always look at this area to look for two things, whether I can find a peak for the carbonyl group or not, and whether I can find a peak for the carbon-carbon double bond. There is no carbon-carbon double bond here. There is only one strong peak here, sharp peak for carbonyl group. So I know that I have carbonyl group, at least one carbonyl group. And then I would look to see whether I have an OH or not. When I look here at the between 2500 up to 3500, where there is this broad peak which gives me the OH, whether for an acid or for an alcohol, there is no broad peak here. So there is no OH. So I know now I don't have an alcohol and I don't have a carboxylic acid. So these three oxygens, none of these is for an alcohol or for carboxylic acid. Then moving on to the carbon-13, which is going to give me more information now. So which of these peaks can give me specific information about the structure? First of all, there are seven different carbon environments, and I have a total of 7 carbons anyway. So all the carbons are different environments. Now let's have a look at the far left of the spectrum. So we can find this peak here at around 210 or 205, and this is a known peak for a carbonyl group from an ketone or an aldehyde. So how can I differentiate whether it's a ketone or aldehyde if I look at the proton NMR? So the carbon hydrogen from the hydrogen or the proton peak from the aldehyde will always be between 9 and 10 parts per million. And when I look at the chemical shift for the proton NMR, there is no peak in this area. So it must be just a ketone. So this is a ketone for me. So now I know I have a ketone. And then this is another peak at 174 part per million. And this is a very well-known peak for the carbonyl from either an ester or from carboxylic acid. Again, I know I don't have a carboxylic acid because there is no OH from the IR. So I must have an ester. So this is an ester as well. Now, what else, what type of information can I get again from the carbon-13? I have this peak here at 60 parts per million. This is the carbon which is next to the oxygen, and the oxygen here, the oxygen from the ester. So now I know this is this carbon here. And I know this carbon that is below 20, it must be a carbon next to another carbon, which doesn't have a carbonyl group or any of these. So just a carbon next to a normal carbon. So this is this one. And then these three carbons here between almost 30 and 40, there must be the carbons which are adjacent to the carbonyl group. Now I have a rough idea about the structure. Now let's look at the proton NMR to get more specific details about the different peaks. So if I look first here at the first peak here, 1.26, it's 3 protons and it's triplet. 1.26 means a carbon hydrogen. This is a proton on a hydrogen that is next to a carbon. And then there are 3 protons here. The integration is 3, so it's a CH3, and it's triplet, so it's adjacent to a CH2. So now I know this is a CH2 next to a CH3 next to a CH2. So these are these protons which are responsible for the first peak. And then the second one is 2.19, 3 protons and its singlet. So 2.19 is the carbon, the carbon hydrogen, which is adjacent to a carbonyl group. And then this hydrogen, there are 3 different protons. So it's a CH3 and it's a singlet. So it's a CH3 next to a carbonyl group. So now I know that I have a CH3 next to a carbonyl group. And then moving on to this one, 2.56, 2 protons and triplet, 2.62 and triplet. Look at these two. These two are very close to each other. And both of these are carbon hydrogen next to carbonyl. Each of these are CH2, and each of these are a triplet. So normally I would expect that both of these will be a CH2 next to a CH2, and each of these will be next to a carbonyl group like this. So there are two CH2, each of these, as you can see, for each of these two protons, each of these next to a carbonyl group. Each of these are triplet because they are adjacent to a CH2. So CH2 next to a CH2, on the other side there is a carbonyl group. And finally, there is this 4.1, which is two protons and a quartet. 4.1 means that it's a hydrogen on a carbon, which is adjacent to the oxygen from an ester. I know that I have an ester from carbon 13 and from the IR. So now I know that I have a CH2 next to this oxygen. So this is CH2. So this is the CH2 next to the oxygen, which is next to the carbonyl group from the ester. And it's a quartet, meaning that on the other side, there is a CH3. Okay, so now let's link all of these together. This is the first CH3 next to the CH2, which is this part here. So now I know I have CH3, CH2, oxygen, and then a carbonyl group. And then I have these two CH2 groups. These are 2.56 and 2.60. And these are two CH2 and CH2. Each of these are linked to a carbonyl group. And finally, the 2.19, this is the three protons on which are a singlet, and these are the CH3 next to the carbonyl group. Now I've used all the data from the IR, the carbon 13, and the proton NMR to deduce the structure of this particular compound. You can use the same technique to identify the structure of any compound using the analytical data. If you have any questions about NMR or IR, or if you have questions that you are unable to answer correctly or you don't understand how to answer, please send it to me or put it in the comment section, and I'm more than happy to go over these questions.